Welcome to COIS ADMN 1620, Introduction to Information Systems. We are studying from the textbook Introduction to Information Systems, the 5th Canadian edition. This is Chapter 1, Introduction to Information Systems. Learning objectives. Identify why being an informed user of information systems is important in today's world. Describe the various types of computer-based information systems in an organization. Discuss ways in which information technology can affect managers and non-managerial workers, and identify positive and negative societal effects of the increased use of information technology. Chapter outline. The chapter is broken into 4 parts. Why should I study information systems? Overview of computer-based information systems. How does IT impact organizations? And importance of information systems to society. As you read through the text in the opening case, the digital transformation of the Canadian Imperial Bank of Commerce, we want you to think about how do you use technology when you do your banking or make payments, and how has technology helped your financial institution. Why should I study information systems? The informed user, IT offers career opportunities, and managing information resources. You as the informed user. You benefit more when you understand what is behind IT applications. You can provide valuable input to your employer, to your situation, wherever you are. You can recommend and help select IT applications. There's an opportunity for students being technologically aware, more so perhaps than the people that are in the existing workforce, to be able to offer both the valuable input and to help select what kind of IT applications will inform and shape the workplace. You should be aware of new technology just by the nature of your exposure, and you should understand how IT improves performance, the time savings and such that come with using IT applications. Understanding IT is beneficial to entrepreneurs. We'll talk about strategic advantages and sustained competitive advantages and things like that in the course. And to really leverage that is of a huge benefit to entrepreneurs. Often entrepreneurs will distinguish themselves solely on their IT expertise or the way they've leveraged IT to be competitive in the market. Digital transformation. Organizations that you work with will be continually undertaking digital transformation, which is the business strategy that leverages IT to dramatically improve employee, customer, and business partner relationships. I would qualify that and say that these organizations should be continually undertaking digital transformation. If they're not, they're at risk of being left behind and therefore losing a competitive edge. New technologies that enable digital transformation include big data, social computing, cloud computing, artificial intelligence, and more. We're going to delve into all of those subjects and more throughout the course. Figure 1.1 is just trying to show what management information systems provide to users that the users can see and what's behind the curtain, so to speak. So we've got IT workers in a large organization that are working behind the screen, so to speak, to set things up so that the users can consume the data for their uses. The more you understand of the process, the more effective you're likely to be. So IT is about Business 1.1, a variety of digital transformation. So things to think about are how digital transformation is changing business relationships, and how those changes increase organizational agility to respond to circumstances. So a great example, of course, is the physical isolation that was imposed on us in COVID-19 and how both schools and organizations overcame those using IT and digital transformation. You can also think about the lasting impact of that transformation. Things like the fact that employees are not wanting to return in many cases to the traditional workplace and how that is complicating both employers and employees' situations. IT certainly offers career opportunities. We've got sort of a mixed bag in the class. Some of the people in the class are taking this from the COIS perspective and maybe learning programming or information system management, those sorts of things. And others are taking it from the ADMN perspective and maybe future accountants and future business executives. So it may not matter to some people whether there is an IT career opportunity, but what will matter to those people is that there's a huge advantage compared to your peers no matter what if you are much more conversant with IT. So IT is vital to modern business. It provides many good and lucrative career opportunities. Those include things like programmers, business analysts, system analysts, designers, and the CIO is the Chief Information Officer. That's from the C-suite, along with the Chief Executive Officer, the Chief Financial Officer, those premier jobs at the very top of the structure of the organization. The CIO is the executive that's in charge of the information system function in its entirety. Career opportunities are going to remain strong in the future. There's always a call for people that are cutting edge and strong in information systems. Some samples of top job rankings, this from Canadian Business. Out of the top 100 in 2019, number 26 is a computer systems manager, 46 is a software engineer, 54 is a database analyst, 56 is a computer engineer. If we look at MSN, out of the top 20, number 2 is a software engineer, number 8 is an IT project manager. The top job rankings according to Forbes are number 2 software engineer, number 4 IT solutions architect, number 11 IT manager, number 13 data engineer, and number 14 the front end engineer, which is the user experience design engineer. Managing information resources. Managing information resources is difficult and complex. The reasons for that are information systems have an enormous strategic value to organizations. If your information system goes down or is ineffective or cumbersome or whichever sort of negative impact there can be, it can have an organizational impact that will hit the balance sheet and the income statement to the extent that the company may not be profitable or maybe less profitable than it should. They're very expensive to acquire, they're very expensive to operate, they're expensive to maintain. We'll be talking about efficiencies in doing all those things, acquiring, operating, and maintaining throughout the course. The evolution of the management information system function within the organization is extremely important as well, and we'll get into that. The factors affecting responsibility for managing information resources. There used to be a very traditional division between the management information system personnel and the end user. In fact, traditionally the MIS personnel or the IT department had sole access to the mainframe because it was a single unit. They were the ones that were responsible for doing everything with that. Now, of course, almost everyone has access to a management information system, and the end user's role versus the MIS personnel role has become much more blended. So there are different responsibilities that are shared through the organization. The important thing at the end of the day is that both the IT personnel, which the book is referring to as MIS personnel, and the end users cooperate to make the management information system as effective as possible. So the new consultative functions of the MIS department facilitate informed user involvement, which is a fancy way of just saying that they are going to talk to the end users, they're going to understand what the end users need, they're going to be there to support the end users' functionality and needs. Traditionally, the MIS department would be taken up with managing system development, so they'd be creating and developing programs and actual hardware incorporation, and system project management. They would be responsible for the computer operations themselves. They would staff, train, and develop information system skills within that department. They would provide technical services to the rest of the company, to anyone that needed them. They would do and be responsible for the infrastructure planning, the development, and the control of all the assets related to the information systems. The new way that things are rolled out in the business world is the consultative function for the MIS department. So I'm not going to go through line by line, but I would suggest that you take a look at the chart, either in the text or here. It's the same content. Understand how the consultative MIS department role looks and what the end user role looks like as well. So for example, if we take the first line in the chart here, we have the consultative MIS departmental role being initiating and designing specific strategic information systems, whereas the end user is going to be on the IT steering committee, mandating development of new strategic information systems. So it's going to be driven by the end user saying, I need this, this is how it has to work. And the MIS department is going to execute on what is needed. And this slide just goes on to talk about more functionalities across the two roles. So now we're going to turn our attention to the overview of computer-based information systems. We're going to talk about data, information, and knowledge, compare and contrast the three terms. We're going to look at IT infrastructure, composed of IT components, IT personnel, and IT services. And we're going to talk about types of computer-based information systems. Data, information, knowledge. So data, according to the text, refer to an elementary description of things, events, activities, and transactions that are recorded, classified, and stored, but are not organized to convey any specific meaning. So data items can be numbers, letters, figures, sounds, and images. Examples of data items are collections of numbers. For instance, you might see 3.2 and 7.9. Or you might see A, B, C, or D, or some combination of them. They lack any specific reference. You don't know what it refers to when it's just data item. It's a collection of data. Information refers to data that has been organized, so now they have some meaning and they actually have a value to the recipient. So we would know that a grade point average, if we were in the States, by itself would be just data, so we might see a 3.1, but if you put a student's name with that GPA, then you've got information because you're relating, you're giving context. First of all, you're letting us know that it is a GPA, and secondly, you're attaching it to the student whose GPA it is. So the recipient of that information can interpret the meaning and they can draw conclusions and implications from the information. Knowledge consists of data and or information that has been organized and processed to convey understanding, experience, accumulated learning, and expertise as they apply to a current business problem. That's within the context of this course. We would be more general and say that knowledge would apply to a current problem in general. But within this course, it's a current business problem. So the example that the text uses is, suppose that a company recruiting you at your school has found over time students with grade point averages over 3.0 have experienced the greatest success in its management program. So they're looking to fast track people into the management program. They're finding that students that have performed well, that have GPAs over 3.0, or that's probably around 75%, 80%, based on the accumulated knowledge that the company has, they can use the GPAs of graduating students to address the business problem of hiring successful employees. So we've taken a step further, we've taken the information and we've applied it against our experience and perhaps a study or whatever, and we can now make some informed business decisions based on the data that became information that is now used as knowledge. Computer-based information systems consist of hardware, software, databases, networks, procedures, and people. We will dive into all those separately. There are, for instance, technical guides on hardware and on software that you will be studying as we go through the course. So hardware are devices. So they're your processor, your monitor, your keyboard, your printer, those sorts of physical devices. Software are programs or even suites of programs that enable hardware to process data. A database is where we store data, the related files or tables that contain data. A network is a system that connects, either wired or wireless, to enable multiple computers to share resources. The internet, of course, is a huge network, but within a business we often have private networks within businesses that allow employees to communicate information and not share them publicly, but share with their colleagues. Procedures are the instructions for combining the components above that are used to process information and generate the output that we're looking for. People, of course, are what uses the hardware, the software, and they interface with it and or they utilize the output. So to summarize, a computer-based information system has 6 basic components. 4 are IT components, that's hardware, software, database, and network. And then 2 are non-IT components, the procedures and the people. The next subject that we want to discuss are the major capabilities of information systems. We don't often really think about information systems in a lot of cases because we take them for granted. They're ubiquitous, they're everywhere, they're all around us. But they do perform high-speed, high-volume numerical computations. That's what a computer does. That's essentially the basic function of any computer, is to perform calculations at a speed and repetition that humans are absolutely incapable of doing. They also provide fast, accurate communication and collaboration within and among organizations. So it's not only within your own organization, but it's within the other organizations that may be suppliers or customers. We will talk about how we can connect with the supply chain later on in the course, and that will involve using our information systems and sharing those resources with people that are supplying us or with our customers to make for efficiencies. We can store huge amounts of information in an easy to access yet small space, meaning that in the old days it would be boxes and boxes and files full of paper. Just if you thought of a large company that might have thousands or millions of customers and that they had to take information for each of those would all be stored on paper previously. So we can obviously store that in a way that's accessible and in a way that is physically not very big. They allow quick and inexpensive access to vast amounts of information worldwide. So we have the efficiency of the cheap storage and access to massive amounts of information. We can interpret vast amounts of data quickly and efficiently. We can comb through what's known as big data and make very accurate predictions and profiling of our customers or potential customers, or test how products may react on the market. And we can automate both semi-automatic business processes and manual tasks. So we want to automate as much as we can if that saves us a bunch of money and saves us time. We're going to talk about types of computer-based information systems from 2 perspectives. 1, the breadth and support of information systems, and 2, the support for organizational employees. Breadth of support of information systems. So there are things called functional area information systems. They're known as departmental information systems. Things like HR, human resources, would have a functional area information system to assist them with their job. Most notably, and probably the most common, would be accounting, an accounting system that may have information that is used elsewhere, but there's going to be a functional area information system for accounting always in a company. There could be an information system for finance, which has to do with how we're going to deal with capital funds, raising and dispersing capital funds, marketing, and production and operations. They may all have different functional area information systems. This diagram sort of shows you the different columns, which are the ones that we just talked about: accounting information system, finance information system, production and operations, marketing and human resources. On top of all that is business intelligence systems dashboards. So those are things that are going to give us at a fairly easy look an analysis of what's going on, interpret the results, and allow us to make predictions potentially. Underlying it all is transaction processing systems. So those are our sales systems, our point of sale systems, and other transaction processing systems. And the absolute foundation to it all is the IT infrastructure, which consists of IT services, personnel, and physical components. Two information systems support the entire organization. The first being the Enterprise Resource Planning Systems, or ERP. They provide communication among functional area information systems through an integrated database. So that's an important concept as to what an ERP is. We've got all these columns that we looked at in the previous diagram with these functional areas, whether that's marketing or accounting or operations. But what we want to do and be very careful about is not to have to duplicate everything. When, for instance, a new customer comes on board, we don't want to have to separately have that customer entered in our accounting system because they're going to pay us, in our operation system because they have an order, in our marketing system as we went through the process of recruiting them or getting them interested in our product. So we want to have a common database. So our Enterprise Resource Planning System, our ERP, is going to use one database, and the functional area information systems are going to draw from that. So we have one copy of each customer, and there will be different aspects as we need it through marketing or HR or operations or accounting or whatever. Then the other information systems that support the entire organization is the transaction processing system. So that supports the monitoring, collection, storage, and processing of data from the organization's day-to-day operations for basic business transactions. So if we have a point of sale system, that would qualify as a transaction processing system. It spans the entire organization. Interorganizational information systems are what I alluded to earlier, and that is they support many interorganizational operations. So supply chain management is a very common use of an interorganizational information systems. For instance, if we use a concept called just-in-time in terms of inventory, so just-in-time inventory process, if we're a large, say, car manufacturer, we may compel our suppliers to use just-in-time. So we don't want to store a whole bunch of parts. We don't want to pay for a whole bunch of parts. We want the parts to show up on our doorstep just as we need them to manufacture the next car. So let's say we're talking about we've subbed out the radios, for instance, in a car, or the entertainment system in a car to be a little more modern. We don't want to have thousands and thousands of entertainment systems sitting around that we've paid for on the floor. We just want enough for today's production. We want not too many and not a short amount so that we can't get through the day's production, but we want our supplier, our outsourced entertainment system, to show up for that day's production. We use it in that day, we pay for it on our terms, and then the next day they cover the next. In order to facilitate that, we obviously have to let our supplier know what our needs are. So we would share with them. We would have an interorganizational information system. We would have a place where they could go and check what their inventory in our factory was, how much we'd used, and what our projections were for the next day, week, or month, or whatever the span of time was that we need to worry about. And then electronic commerce, e-commerce systems. We have a bunch of different e-commerce systems, business-to-business systems where we have transactions between companies. Information systems that function among multiple organizations. This is a good diagram just showing us how our suppliers are relating to our organization, how we're doing business-to-business electronic commerce, so B2B e-commerce, and how our customers are interacting with us through online orders, payments, and we're potentially sending them digital products all through the information system. So those are business to consumer, electronic commerce, or B2C. So take a look at the diagram. It does a pretty good job of showing us how both electronic products and physical products flow and how we are functioning amongst multiple organizations. It's about business 1.2. There's a section in the text that talks about TRIEC helping Canadian newcomers find a job. And what you should do is you should consider, how can technology support a mentor for you in your future career? And how is your online education supported by email systems? Those are sort of a couple thoughts to ponder. You may see questions like this show up in the discussion, in the brief short answer discussion questions that I assign throughout the course. Support for particular organizational employees. All types of workers require support from information systems. Clerical workers, managers, knowledge workers. The knowledge worker concept is something we'll come back to. The systems that support them are called the functional area information systems. We already talked about that, whether that's for accounting or marketing or operations. Business analytics and business intelligence. Those are ways that we look at our results and project into the future what we're going to do, what direction we're going to take the business. Expert systems support higher or more sophisticated functions. And dashboards, also known as digital dashboards, are there to allow us to monitor our processes and to monitor our results. Table 1.4, types of organizational information systems. Again, I'm not going to go through this line by line, but I would strongly suggest that you do. I'll take an example of an expert system. So an expert system, the function of it is to mimic the human expert in a particular area and make decisions. So the example of an expert system that's used is credit card approval analysis. So that expert system would take the information input through the application and do tests on various metrics, including credit rating and such, and recommend whether that customer be added as a credit card customer or not. How does IT impact organization? So IT doesn't just impact organizations, it impacts entire industries. IT reduces the number of middle managers. IT changes the manager's job. Will IT eliminate jobs? And IT impacts employees at work. We're going to go through all these 5 subject matters in the next few slides. IT impacts entire industries. Examples. So the book goes into some really good examples, but probably we can think of examples fairly quickly. So the book industry, the music industry, video industry, software industry, video game industry, photography industry, marketing industry, and recruiting industries. So the use or the development of IT has had an enormous impact. So if we look at the book industry, books used to be printed hard copies, and now they're available electronically. You can order a book electronically and get it within seconds of the time that you pay for it, as opposed to having to go to a store, pick up a book, browse through it physically. You can already have a good idea what that book's about. You can see ratings on the book. You can be advised as to related authors. Perhaps that book will come up as a suggestion based on your previous reading history. The music industry, of course, was greatly impacted by the development of both iTunes and sharing networks where pirated music was distributed freely, and at one time the video industry similarly. So there's lots of examples where entire industries are impacted. So another slide of impacted industries, financial services. We're starting to see that with blockchain. And one of the big concepts that we talk about with the impact of entire industries is disintermediation. So disintermediation is the concept of getting rid of the middle guy. So instead of having to go through a retailer, maybe you can buy directly from the wholesaler through the internet. So, or even from the person that's actually producing it. So you cut out the wholesaler, you cut out the retailer, and you're buying factory direct essentially. So that's an example of disintermediation. Motion picture industry, they're starting to deliver not to actual theaters, but to stream online. Automobile industry, where we can use Mr. Elon Musk as an example, and the way he is distributing his Tesla vehicles as opposed to having dealerships everywhere. Agriculture, fashion, education, legal profession, there's really not any, or there's not many industries that haven't been impacted to some degree by IT, but these are some of the ones that have been really significantly impacted. The book does a good job of talking about examples. IT reduces the number of middle managers. It makes middle managers more productive. It used to be that you had a certain number of employees, they would have a manager, and then a certain number of managers would be a middle manager, and then a certain number of those middle managers or regional managers would be overseen by a higher level manager. IT increases the number of employees reporting to a single manager, so it's going to reduce the number of middle managers required because they too are likely to be able to have more managers reporting to them. So it reduces the middle layer of management and makes your organization a lot flatter and a lot wider instead of being so structured with, say, a 4-to-1 ratio, 4 employees, a manager, 4 managers, a middle manager, 4 middle managers, a senior manager, that sort of thing. IT changes the manager's job. What managers do has changed because of IT. Decision making is the most important managerial task. That's what managers do. They make decisions. But IT changes the way they make decisions because you get near real-time information. You're not having to guess as much. You can actually use hard data. You can see production data. You can see sales data. You can see it in real time in a lot of cases. By the nature of competition, managers have less time to make decisions. Things are moving faster. Other companies and other managers are making decisions faster. They're able to steer the companies in a more profitable direction. They can keep a competitive advantage by the speed at which they react to the information that's flowing in. IT provides tools for analysis to assist in decision making and in handling high volumes of information. Humans don't do all that well with really high volumes of information. We tend to see patterns that don't necessarily exist, and it's so much better to have analytical software that can pull actual trends out and maybe present trends and results in dashboards where we can see what's happening instead of relying on our intuition. We can use actual data to inform our decisions. Will IT eliminate jobs? The competitive advantage of replacing people with IT is increasing rapidly. Labor is expensive. IT is also expensive, but doesn't need sleep, doesn't form unions, doesn't go on strike, those sorts of things. The increasing use of IT in business creates new job categories. So we talked about some of the top jobs. Many of those jobs, I worked in the United States under a NAFTA agreement, meaning that I had a work visa under NAFTA called a TN1 work visa, and that was specifically driven by job descriptions. So there were 20 or 30 different job descriptions. Unfortunately, NAFTA was an old agreement, and there were many jobs that you couldn't qualify under NAFTA to get a TN1 work visa because that job title did not exist when NAFTA was conceived of. So there are all sorts of new job categories. The use of IT requires more employees with IT knowledge and skills. If you're going to be in many industries and you're not interested or conversant with some degree of IT, you're putting yourself at a huge disadvantage. Or conversely, if you want to look at it in a different way, if you are IT savvy, you can put yourself at an extreme advantage against the people that are your peers by being able to use information systems more effectively, being able to understand them and assimilate their use into your job. So whether you look at it from the negative perspective or the positive perspective, there is an advantage to being able to use IT in business. It has an impact on employees' health and safety. There is more job stress. There's no question about that. Sitting in front of a computer for 8 hours a day is not a natural occurrence. We're not built that way. It is very easy to do. I've made a career of doing lots of that. But even the long-term use of a keyboard and mouse can give problems with wrists and elbows and joints and necks and things like that that are called repetitive strain injuries. So we need to mitigate that in the workplace, and we use ergonomic products that protect the users of computers, people that are sitting there. There's a 20-20-20 rule that you're supposed to follow, and that is every 20 minutes, take your focus away from your screen, look at least 20 feet or meters, I'm not sure honestly what it is, look 20 feet away and focus away, and do that for 20 seconds. And that tends to help you mitigate some of the eye strain that comes from staring at a computer all day. Now, computer monitors are designed better than they used to be in terms of their emissions and such, but it's still not probably the best thing to just be staring at a computer screen for hours and hours every day without a break. So there's other more physical devices such as the pads to support your wrists when you're on a keyboard. I'm actually standing at a standing desk right now. I have a desk that adjusts up and down. I spend most of my day standing as opposed to sitting now. I love that. It just feels a lot better than being seated all the time. I work a regular job in addition to being a professor, so I generally work in front of my computer for 10 or 11 hours every day, maybe a little less on the weekends, but I'm in front of a computer an awful lot of time. And the health benefits of me being able to stand as opposed to being seated for 70 hours a week should be enormous over time. IT provides opportunities for people with disabilities. So we've got built-in software that can do speech recognition for employees that can't type, for instance. Maybe they have a physical impairment and they're unable to type, so we can dictate verbally. We can use audible screen tips for employees who are visually impaired. I have a brother-in-law that is legally blind. He's completely blind, and he has worked for years for the government in northern Quebec, and he has all sorts of software that reads incoming email for him, reads PDFs for him, reads Word documents, and allows him to function well with the information that's presented in a format that most people would simply read using their vision. The importance of information systems to society. IT affects our quality of life. We've started to talk a little bit about that. The robot revolution is here now. IT impacts healthcare and the emergence of cognitive computing, and we'll talk about IBM Watson specifically. IT affects our quality of life. It certainly changes the way we work. We have smartphones, whether you love them or hate them. They provide constant access to text, email, and voice communications. I just had an interaction, a nasty interaction with someone at the theater that decided that they would take out their iPhone or whatever device it was and text during the movie. Not only is it ignorant and distracting, it's infuriating that someone would think that that was an appropriate thing to do. So, not being shy, I voiced my opinion, and that person put their phone away, turned it off, and the rest of us were able to watch the movie without distraction. The lines between work and leisure time have become blurred. I certainly take text messages, emails, and respond to students at all hours of the day and night. I don't set a limit, so I won't arbitrarily say that my day for responding to students is 9 to 5 or anything like that. I have no problem responding to students at 10 o'clock at night if I'm on my laptop or if I'm available to do that. I'm not going to stop my recreational activity, presuming I'm doing something recreational at 10 o'clock at night, nor am I going to get out of bed at 11 or midnight and get up and respond. So manage your expectations, but there is definitely a big blurring between work and leisure time. We're always connected. Now there is legislation that's starting to come in Ontario and through Canada. It's already through a lot of Europe that prevents employers from arbitrarily reaching out to their employees in off hours. So I'm starting to see signatures in people's emails saying, I recognize that you may not be working the same hours that I work, so I'm not expecting an immediate response. So in that and related to that, manage the expectation. An email is an asynchronous communication, meaning that we're not connected. It's not a chat, it's not visual, it's not a Zoom session. So your expectation should be somewhere between 24 and 48 hours for a response to email. Now, a lot of people respond a lot faster than that, but that should be a reasonable expectation. That's an expectation at the level of this school, though I don't think Trent specifies that. They specify that instructors should respond in a timely manner, but I'm not sure that it's specified. In Fleming College, where I also teach, the time is 48 hours. You are expected to respond to any email within 48 hours. That may seem very slow to some people, but it allows people to manage their time and control that off time and prevent some of that blurring. Surveys indicate employees take laptops and smartphones on vacation. Sure, if you've been on vacation recently, probably pre-COVID, maybe a little bit post-COVID, if you look around, you'll see entire families sitting at a table eating out in a resort, and they'll all be on their phones. Often the parents have laptops and they're working from their rooms even when they were on vacation. Whereas traditionally, when you were away from the office, you were truly away from the office. No one could get a hold of you, no one could interfere, and you would have some much more serious downtime. The upside, of course, to the quality of life being impacted by this is that we do a much higher volume of work than we used to. By the fact that if you're on 2 weeks vacation, you're still responding to email at some pace is much better than having to work like a maniac before you go on vacation to get all your work done. And then when you came back after a week back in the office, you wish you'd not taken your 2-week vacation because you're so inundated with the work that you had to catch up. The robot revolution is here now. So we've got some examples here: Baxter, Lobots, drones, autonomous vehicles. We are getting there. You can see how technology is developing, how self-driving vehicles are just around the corner, presumably. And the reality is that if you were stuck in rush hour in Los Angeles right now, there would be a lot of Teslas and other electronic vehicles that would be driving through the traffic jams, meaning just inching forward without any person having anything to do with that. Now, I don't believe that's legal yet in California or anywhere else, but the reality is, if you look on YouTube, you can see videos of drivers completely asleep in the LA traffic jam, inching along, getting 40 winks while their car drives itself. So another business case from the text, IT's about business, or it's about business, diverse uses for drones, and they want you to read that section and then consider how are drones and robots helping with our food supply, and how could drones help reduce crime in your area, town, or city. So those are some things to think about. Again, these are the kinds of topics that would be useful for me as an instructor to test your thoughts on in a short answer question. IT impacts healthcare. IT is used in healthcare to make better and faster diagnoses, streamline the process of researching and developing new drugs, enhance the work of radiologists, and allow surgeons to use virtual reality to plan complex surgeries and use robots to remotely perform surgery. I've seen videos of surgeons performing intricate procedures using robots to scale things down to an almost microscopic level, where they are connected to the robots looking at something visually, not necessarily even in the same room, transmitting a signal so that they can perform that very complex surgery using the micro appendages of a robot. So streamlining the process of research and developing, there's a lot of computer modeling that's going on that will cut out some of the time, that can eliminate some of the false steps that might have been taken in a trial and error approach previously that might take months of research. If you can model it and get an effective model developed, you can maybe save yourself a whole bunch of development time, which means that you come to market faster and save costs in getting there. The emergence of cognitive computing, IBM Watson. So IBM's Watson is an artificial intelligence application. It's called cognitive computing. So Watson can understand natural language. Watson learns and absorbs information and formulates hypotheses from that information, and has the ability to understand the context of a question. So that's really important. In other classes, I talk about the way Google works and the underlying algorithms that Google uses to sort and classify, and then take a look at the queries that you're putting in. So that's an ever-evolving area where what you say into Google gives you better and better results. It understands better what it is you are asking for. In healthcare, Watson helps fine-tune diagnoses and treatment protocols, and Watson's being used in other areas, including things like customer service, financial services, tax preparation services, and strategic analysis. So take a look at the section in the text that talks about Watson. I think it's pretty fascinating information, and it's a real glimpse of the future of artificial intelligence. So the last case is John Deere becomes a technology company, and it is not all good news. I love the headline because it catches your interest, and it's like the headlines you see when you're browsing the internet that send you down a rabbit hole of information that you weren't even specifically looking for in the first place. In this case, they want you to think about how technology has helped farmers work more precisely with their crops and with other partners. How much could that be worth? Should software maintenance for any product be locked in to specific suppliers, or should it be more readily accessible? So that's the concept of open source versus closed source or proprietary information. Should this be shared amongst everyone, or is the profit motive acceptable, or what combination is appropriate in that case? That brings us to the end of this chapter's lecture. Thank you for your attention.